G is placed on a plane which is inclined at 40 degrees to the horizontal. The box is kept in equilibrium at the point of moving up the plane by a light string which lies in the vertical plane containing the line of greatest. Okay, so all the forces are coplanar. The string makes an angle 20 degrees with the plane as shown in the figure. The box is in limiting equilibrium. Okay, and
Yes.
tension in the string is given as 10 newtons. Coefficient of friction is mu. We have to find mu. Okay, ready? Let's put all the forces on this. So vertical force is how much? The box is weighing 1 kg, so this will be just G, correct? Then we have to take perpendicular force. Have we done this? Hey, 12th one is over now.
Uh,
Yes, 12th one is over. That was the last problem we did yesterday.
Nice.
So we have to go for the next one. 13th one is also complete. 13th one is also done. So chapter review, we have to start with the chapter review.
Yes.
Okay, shall we do it?
Okay, sir.
Right, so let's take this. So 12, 13 is over. Next one. A particle is acted upon by three forces as shown in the diagram. Given that the particle is in equilibrium, work out size of the angle theta. So theta we need to find, and we need to find the force P. So he's telling us that they are in equilibrium now.
Yes.
Equilibrium. So three forces, they are coplanar, they are all moving away. So which theorem can we apply?
Lami's theorem.
So Lami's theorem. Okay. So what does Lami's
Yes.
theorem tell us? So force, let's say 12 divided by sine of opposite angle. The opposite angle is here, this one. So what is this angle? Okay, this is a bit complex, right? So
Yes.
75 plus 90 minus theta, no?
Yes.
This is the angle here. So this is equal to, let's take the next force as P. So if P is the force, we need this angle. How much is that angle? Sine of
Sine of 70 plus 90 minus 30.
70 plus 90 minus 75. And the last force is 10 Newton. And the angle opposite is this angle. What is that angle? So this angle is 90 minus 70. Correct?
Yes. Yes.
Then this angle is 90. And then this angle is theta. So we have to add all these angles, right? Correct?
Yes.
Okay. So so we have to form equations from these things. I think Lami's theorem is going to be very complex here because he has not mentioned which method to follow. We can use any method, and Lami's theorem, you can see it's becoming very complex. Theta is not coming alone.
Yes.
So solving for theta will be very problematic. Instead, if we can go with sigma v and sigma h, that will be much easier way to go. Okay, so let's reject this. Let's go with the sigma. Sigma, which one you want to go? V.
Okay, sir.
Take all the vertical forces over this. So what is the vertical component of 12 newtons?
12 sine 70.
Yeah, 12 sine 70, and it is acting upwards, so plus. Then what is the component of 10 newtons?
10 cos 75.
Cos 75, and it's acting downwards, so minus. And what is the component of P?
P sine theta,
P sine
and
theta,
it's negative.
negative. So this total should be 0. So we get P sine theta equals, what do we get?
Mm,
We can do the calculation. Let's take the calculator. Give me a minute.
okay, sir.
Okay, so there we go. Okay, so solve this out. What do we get? 10 into cos 70 cos 7, no, sorry, yeah, cos 75, then minus 12 into sine 70. Okay, that is okay. This is minus, that side we get minus 8.688. Okay, minus minus will cancel out. We get P sine theta as this
Yes,
value.
sir.
Then horizontal components we need to take. So take all the horizontal components. First let's start with P. So P cos theta, then minus 10 sine 75, again minus 12 cos 70. This total should be 0. So we get P cos theta equals how much? Ten into sine. Give me a minute. Yeah. No, ma, come on Monday.
13.76.
Yeah, 10 into, yeah, 75 plus 12 into cos 70, 13.76. This is equation number 2. Now using 1 and 2 we need to find P and theta. How can we find it? Isma? Equation 1 divided by equation 2, if we do, P and P will cancel. Sine by cos we will get left side. Right side we will get 8.688 divided by 13.76, right?
Yes.
So this is tan theta. So theta will be equal to tan inverse of this value. Okay. So find tan inverse 8.688 divided by 13.76, 32.27. Okay, so this is the angle
Yes.
in degrees. Now if we substitute angle in one of these equations, we will get the value of P. So P will be, let's say, second equation, 13.76 divided by cos of 32.27. Okay, so we substituted it here.
Yes.
What do we get? So 13.76 divided by cos 32.27, that's 16.27.
Yes.
This is in newtons. Okay, so this is the angle and this is the magnitude of P. Okay,
Yes.
Any doubts here?
No, sir.
Okay. The next question is coming here. Let's take this. Whoa. Okay, so here we have the next question. So we have a particle which is acted upon by three forces as shown in the diagram. Given that it is in equilibrium, find the size of angle theta. So theta is over here, okay? And we have to find the magnitude of W. So are we supposed to take any normal reaction here? No, we should not take it. So we are supposed to find the angle theta. Angle theta and W2 are unknown. Alright, so let's take up, this will be our y-axis, correct?
Yes.
This will be our y-axis, and this will be our x-axis, right?
Yes, sir.
So x and y-axis. So this angle here will be theta, no?
Yes, sir.
Okay. So now we need to start solving it. So sigma y direction, let's take y components all. So 30, the component is sine 45.
Yes, sir.
And it is acting upwards. Then for 40, component is 40 sine 30. Again it's acting in positive y direction. Whereas W cos theta, no?
Yes.
This one is acting in negative y direction, so minus. This total should be 0 because the object is in equilibrium. So W cos theta, you will get the value. If we send it to the other side, it becomes positive. This value we need to find. What do we get? So that is 30 into sine 45 plus 40 into sine 30. 41.21, right?
Yes.
41.21. So this becomes equation number 1. Then sigma x, take all the x components. So for 40, the x component is 40 cos 30, and it's in positive x direction. For 30 newtons, it is 30 cos 45 degrees, but it is acting in negative x direction, so minus. Then W sine theta, and it will act in this direction, that is opposite to x, so minus. So total should be 0. Once again send sine W sine on other side, we get W sine theta equals, do the calculation, 40 cos 30 minus 30 cos 45, 13.43, correct?
Yes.
This is equation number 2. So once again we have it in W sine theta, W cos theta format. So this time let's do equation 2 divided by equation 1, because we want tan theta, no?
Yes.
So W gets cancelled, we get sine theta by cos theta. Sine theta by cos theta, that's nothing but tan theta. This is on the left side. On the right side we get 13.43 divided by 41.21. So theta will be tan inverse of this. What do we get? So tan inverse 13.43 divided by 41.21, that's 18.05
Yes.
degrees. So now we have the theta value. Let us substitute in one of the equations, and that equation will give us the value of W. W will be equal to 13.43 divided by sine of angle theta. Theta is 18.05. That's what we found just now. So find this value, 13.43 by sine 18.05. That's 43.34. This is in newtons. Okay.
Yes.
So this is the magnitude and this is the direction of our known force. Okay. Yeah, this is the angle of slope, actually not the direction of W. This is the angle of slope and this is the magnitude of weight. Okay.
Yes.
Let's take the next one. This one is over. Third one. So okay. Alright, so an acrobat of mass 55 kg is standing on the tightrope. By modeling the acrobat as a particle, tightrope as a two inextensible strings, calculate the tension in the tightrope on each side of the rope. So if you take free body diagram, so this is the person who is standing. Okay, so for
Yes.
now we are considering that person as a particle and the weight of the particle will be acting downwards. How much? That is 55 kgs. Kgs gives us the value of mass, but we want here weight, so m into g we need to take. Fine, where g value is 9.81. Okay,
Yes.
then these angles are 20 degrees, so let's take it like this. So this angle will be 20, this angle will be 10 degrees, right?
Yes.
So then this side tension, let's take T1, this side tension, let's take T2. So we are supposed to find tensions T1 and T2. So let's proceed. Again, I think for this we can go with Lami's theorem. Okay.
Yes.
We can go with Lami's theorem. Angle theta is not that complex. We can directly put it. So first let's take T1. T1, the opposite angle is this. So T1 sine, T1 divided by sine 90 plus 10. No?
Yes.
So that is equal to the weight 55g, that divided by sine of this angle. How much is that angle? 180 minus 20 minus 10. है ना?
Yes.
180 is straight angle minus these two angles will give us this. And then we have T2. The angle opposite to T2, that is this angle. That is how much? This angle is 90 plus 20. Correct?
Yes.
So now that we have all the three relations, we can go ahead and solve T1 and T2. So first take these two. You will get T1. T1 equals, so this becomes cross multiplied, right?
Yes.
So we get 55 into G. G is 9.81 into sine 90 plus 10. 90 plus 10 is 100, no? Divided by
Yes.
sine this total angle. Total 180 minus 20 minus 10. That is 180 minus 30. Okay. So that is giving us 1062.71. Correct?
Yes.
So this one is in kgs. So when we convert, we will get it in newtons. So tension is in newtons. The same way we need to find tension T2. So in order to find the T2, we have to take these two equations. Okay. So take those two equations, we get T2. Again cross multiply. So this goes upwards. What do we get? We get okay, let's use the same one. So now the angle is 90 plus 20. 90 plus 20 is 110, right?
Yes.
This gets multiplied in numerator, everything else remains the same. So 1014. 014.02 in newtons. Okay, so
Yes.
these are the values of tensions. Any doubt here?
No, sir.
Okay, so next let's go for the fourth one. Mhm. Okay, so particle Q of mass 5 kgs. So 5 kg means this should act downwards. How much? 5 kgs. 5 kg means force we need to take now. Weight will be 5 into
Yes.
g. Again, g value is 9.81 meter per second square. Rest on the smooth inclined plane. The plane makes an angle theta, that is here. Tan of theta is given to us. Tan of theta is 3 by 4. That means, okay, so let's draw it here. If this is the angle theta, tan of theta is opposite by adjacent. So 3 and 4 will come here. Hypotenuse will come out as 5 by Pythagoras theorem. So from this, okay, so this we got gave us the triangle. From this we got this sine theta. Sine theta is opposite by hypotenuse, and cos theta is adjacent by hypotenuse. Correct?
Yes.
So these we will need to use in the equation. The plane makes an angle theta. Q is attached to one of the end. So what is okay? So what is the weight on this side attached to a particle of 2 kgs, right? So this one here
Yes.
is 2g. G value is again the same. Particle Q is also acted upon by force F. The F is acting over here. That's acting horizontally, right? Horizontally. So okay, what are we supposed to find? Particle Q is acted upon by force F, as shown in the figure. What is he asking to find? I think it's going in the next page. Yeah. So these all we need to find. The question is big, very big. Okay. Okay. So first we need to find the force F. First we need to find the force F. So for that, so we should take which method? XY method, no?
Yes.
So this is our y-axis. Oops. And this will be our x-axis, right? Let's take in dotted form. This is x-axis and this is y-axis. So this angle is how much? The angle of weight will be same as theta, correct? And
Yes.
this angle is also theta because alternate interior angles are there. Okay. The pulley
Yes.
is smooth, so whatever tension is there on this side, same tension will come here. Tension will be equal to the opposite angle, right? So 2g. Here also it will be equal to 2g. Then there will be an upward reaction here. A reaction, let's call it as R. So total, how many forces are acting on the particle?
Mm,
So we'll have to take this one. Okay. So we have to take free body diagram of this to solve the value of F. Okay. So here T is how much? T is 2g now. Correct. So here friction also should be ignored. Nothing, no information is given on the friction, and he's telling the plane is smooth. Smooth plane means zero friction, so no friction on this. Okay.
Yes.
So four forces are acting. Again, we have to take sigma y, take all the y components. R is acting in upward direction, positive y direction. Then next 5g. What is the component of 5g in y direction? 5g cos theta. That is acting in negative y direction, so minus. Then f sine theta, correct? F sine
Yes.
theta will also act downwards, opposite to y-axis, so minus. And tension T is parallel to the plane, so it won't have any y component. Total should be 0. And sine theta and cos theta values we know it, right? Sine theta and cos theta values we know. Sine theta is 3 by 5, cos theta is 4 by 5. So here what is remaining unknown? R is the only unknown, no?
Yes.
No, R and F, two unknowns are there.
Uh,
So find it. So F equals R equals 3F by 5 and plus 4, 5 will cancel out. So this is okay. On the other side, this becomes positive. So 5g into 4 by 5. 5 will cancel. We are left with 4g. Correct?
yes.
So this, let us call it as equation 1. Then let's go with sigma x. All the x components. Take them out one by one. So t is acting on the right side. Then okay, f cos theta. F cos theta is also acting on the right side. R will not have any component in x direction. 5g into sine theta, and that is acting in negative x direction, so minus. This total should be 0.
Yes.
So now here we don't have, so here everything is known except f now. So we can
Yes.
find value of f. So first of all, let's substitute cos theta is 4 by 5, 4 by 5. Sine theta is 3 by 5. So we are supposed to find f. So 4f by 5 equals t. T is how much? T is 2g. So minus 2g plus this 5 cancel. So 3g. Correct?
Yes.
That will give us just g. So f will be equal to g into 5 by 4. So what do we get? G is 9.81 into 5 by 4. 12.26. Okay.
Yes.
12.26 newtons. So this is the value of horizontal force F. So A bit is done.
Yes.
A bit is done. Then normal reaction between Q and the plane. So normal reaction is here. So we have to take this value of F and substitute here. Okay.
Yes.
So R equals 3 by 5 times F. F value is 12.26 plus 4g. Correct?
Yes.
So do this calculation. So 3 into 12.26 by 5 plus 4 into 9.81. So we are getting 46.60. Okay, newtons.
Yes.
So this is the value of R. So this has solved the B bit. So B bit is also solved. Then the plane is now assumed to be rough. Rough means now he is adding friction. State with a reason which of the following statements is true. F will be larger, F will be smaller, F could be either large or small. So first, what is the definition of F? So F is okay, particle Q is acted upon by force F. Uh, so will it remain in equilibrium?
Um,
F could be large or small, no?
yes.
Because if we are trying to apply minimum F, friction will help us. So when the friction helps us, the F value will reduced. But if you want to push it upward side, if you want to push the block on the upper side, friction will be blocking us. That's what will increase the value of F required to move it upwards. So for a range of values for F on both sides of the value we got just now, it will remain in equilibrium, right? So the third option is correct. It can be large or small. It will be large when it will be large, if we want to move upwards, upward motion. Okay. And if
Yes.
we want to take the downward motion, it will be less. Not motion actually, starting motion, right? So that's the thing. So any doubts here?
Um,
Okay. So next, the fifth one. Right. So it's still saving. Okay. A smooth bead B of mass 2 kg. So bead is there. Okay. So
yes.
if this is a bead, that means it is going through the string and there won't be any friction considered, right?
Yes.
Correct?
Yes.
So what will be the tensions on both the sides? Are they different or same? Tension on these two strings, will it be same or different?
Yes. Same.
It will be same. Okay. So this, because this bead acts like a frictionless pulley, and then this angle here will be 20 degrees because alternate interior angles. This angle here will be 70 degrees, correct?
Yes.
Tension, let us call it as T. Both tensions will be equal, so let us represent them with single alphabet. P is acting on this side. Okay, so what are we supposed to find? A bit. Show that the tension in the strings is 33 newtons. So T we are supposed to find first. How to find T? Should we take sigma V or sigma H?
Um,
If you take sigma H, then P will also come. No? P is unknown. T is also unknown. So
yes.
two unknowns we will get. Is it possible to have a single unknown?
Um,
If we take sigma vertical, P is horizontal, so it will not have any vertical component. So only one
yes.
unknown, that is T, will be there here. So it's better to take vertical component. So now
Yes.
find all the components. Vertical component of upper T is T cos 20. Then vertical component of lower T is minus T cos 70. And then weight is minus 2g. Correct?
Yes.
So this will not have any vertical component. This total should be 0. So find the value of T. T will come out common. Cos 20 minus cos 70 equals 2g. Correct? So tension T will be equal to, do the calculation. So this will be 2 into 9.81 divided by cos 20 minus cos 70. That gives us 32.83. Okay,
Yes.
in newtons. So first bit is solved. This is the answer to A bit. Next, what is he asking next? B bit. Calculate the value of P. Now for P, let's go with sigma H, the horizontal components. Take all the horizontal components. So P is acting right side, then horizontal component of T is minus T sine 20, then the lower T is minus T sine 70. 2G, this weight is vertical, it will not have any horizontal component. So now we can find the value of T. Send both the T's to the other side, both will become positive. So 32.83 can be taken common into sine 20 plus sine 70, correct?
Yes.
42.08 newtons. So this gave us the value of B. Okay, any doubts here?
Yes. No, no.
All right, so let's go with the next problem, sixth one. Okay, a box of mass m kg sits stationary on a rough plane. The plane is inclined at an angle of theta to the horizontal. Okay, plane is inclined at angle theta. Coefficient of friction is mu. Show that when the box is on the point of slipping, theta is equal to tan inverse mu. Okay, so let's take a plane like this. Actually the plane is inclined, right?
Yes.
So let's keep the box like this, and this is actually inclined, correct? So now it's inclined, and now let's take all the forces. So what are the forces acting? This force is downwards. Downward force is how much? Mass m kg is acting on this, so mg will be the downward force. Then normal reaction will be here like this. This is the normal reaction. Let's call it as R, and it is just at the on the point of slipping. It is at the point of slipping. So that means friction will act in which direction? Downward or upward? It's trying to
Upward.
slide downwards. This is the
So it like upwards.
yeah, this is the tending motion. So friction will be opposite to the tending motion, and because
Yes.
it is about to slip, this will be equal to mu times R, correct?
Yes.
Are there any other forces acting? No other forces acting, no?
No.
So this angle he is telling it is theta. Same angle will come over here, right?
Yes.
So now yeah, now we again have to take x axis, y axis. So shall we start with y component, sigma y? Okay, so sigma y, what are the components? R is acting upwards. Component of mg, that is mg cos theta, it is acting opposite to y direction, so minus. This is along x axis, it won't have any y component, so total should be 0. R will be mg cos theta. Next, if you take x components, mu into r is acting in positive x direction. R will not have any x component. mg, so mg sin theta, है ना? mg
Yes.
sin theta, it is acting opposite to x direction, so minus. This also should be equal to 0. So mu r equals mg sin theta, and if we substitute the value of r here and send it to the other side, we get mg sin theta divided by r, and r is equal to mg cos theta, correct? The mg and
Yes.
mg will cancel. Sin theta by cos theta is tan theta. So that proves that theta is equal to tan inverse mu. So hence, therefore, or hence proved. Okay. Any doubts here?
No.
Next we have the seventh one. Okay, so we have next question here. A particle of mass m kgs. A particle of mass m kgs lies at rest on a rough horizontal surface. A force of magnitude 1 by 5 mg is applied to the particle at an angle theta to the horizontal. Given that the particle remains at rest, show that mu is greater than or equal to cos theta by 5 plus sin theta. So this time we have to take a horizontal surface, horizontal rough surface, and let's say this is our block. So what are the forces acting on this? Okay, so downward force is how much? Downward force will be m into g. Upward reaction, let's call it as r. A force of magnitude 1 by mg is applied to the particle theta to the horizontal. Okay, so is it pushing or pulling? That has not been told to us. So let's take it as being pulled. So this is mg by 5 or 1 by 5 mg. Okay,
Yes.
mg by 5, this is the force, and this is acting at an angle theta here. So given that the particle remains at rest, we have to find the relation for mu. Okay, so friction will be maximum, no? Maximum friction is limiting friction, and that limiting friction is mu times r. This is the maximum friction that any surface can provide. So let's calculate for maximum value of friction, and then we will write it in this format. Okay, so again we have to start with a vertical component. Vertical component, r is acting upwards, mg is downwards, and then mg by 5 component of this vertical component is acting upwards, that is sin theta. This total should be equal to 0. I get the value of r. On the other side, mg I can take common. I'll be left with 1. This becomes minus sin theta by 5, correct?
Yes.
Then horizontal components I need to take. So we get mg by 5 into cos theta acting in forward direction minus mu r, this is acting in backward direction. So here we need to substitute the value of r. Substitute the value of r here. So mg by 5 cos theta, so this should be equal to 0, of course. Mg by 5 cos theta minus mu is not known, r is mg into 1 minus sin theta by 5. Now we are interested in finding mu, so keep mu on one side, send everything to the other side. So mu mg 1 minus sin theta, we have sent it to the left side. Right side we will have mg by 5 into cos theta. So mg and mg will cancel out, and mu will be equal to cos theta by 5, and we need to take reciprocal of this, right? So in order to
Yes.
take reciprocal, first let us apply LCM here. Let's apply LCM here. So we get 5 here. So we get 5 by 5 minus sine theta. So 5 and 5 will cancel. So mu equals cos theta by 5 minus sine theta. Okay. So this is
Yes.
for maximum friction. This is for maximum friction. Friction can be less than that also, no?
Yes.
So friction can be less than that also. And that's the reason we will get here friction has to be, the mu value has to be greater than or equal to this. Mu value has to be greater than or equal to this. If mu value is less than this, the object will start sliding. Correct?
Yes.
If mu value is less than that, object will start sliding. And in the question we have been given that it is at rest. Hence, this is, the mu value has to be greater than this. Hence proved. Let's see what we have next. So this is 7th one is over. 8th one. Diagram is not given for this one. This diagram is for the 9th one. So let's take this. Right. A particle of mass 5 kg is stationary on a rough horizontal plane. Force of 5 Newton is applied on an angle tan inverse 4 by 3 to the plane. Given the particle is on the point of slipping, show that mu is equal to 1 by 15. Okay. So once again, we have not been told whether it is being pushed or pulled. So let's first put it anyway. So this is the mass 5 kg. Mass is 5 kg here. The downward force will be how much? 5g. Downward force will be 5g. Okay, let me take in a different color. The downward force is 5g. Reaction upwards will be r. Then again, force is acting. Force of 5 Newton is acting. So 5 Newton is acting and at an angle. So this angle, let's say it is theta. So this angle theta is equal to tan inverse 4 by 3. Tan inverse 4 by 3. Given that particle is in the point of slipping, the particle is about to start moving. That means friction is equal to limiting friction. So mu times r. So these are all the forces that are acting on the object. These are all the forces that are acting on the object. So let us start solving it. So we have to find mu value. We have to find the value of mu. Okay. Yeah. So again, start with sigma vertical or y. R is upwards minus 5g. Then plus 5 sine theta. Correct. Then mu r is horizontal. It will not have any vertical component. Total should be 0. So what will be sine theta? So here we have been told that tan of theta is equal to 4 by 3. Tan of theta is 4 by 3, opposite by adjacent. So this is angle theta. 4 by 3 now. 4 by 3. 4 by 3. So this will be 5. So that means sine of theta will be 4 by 5 and cos of theta adjacent by hypotenuse is 3 by 5. So knowing these values, we can start solving it. Let me take this, keep it. Yeah. Okay. So now, yeah, sine theta is 4 by 5 now. So r will be equal to 5g minus 5 into 4 by 5. 5 and 5 cancels. We get 5g minus 4. So 5g minus 4, do the calculation. 5 into 9.81 minus 4, 45.05. R is 45.05 and 04 newtons. 05 now. Correct?
Mm.
Then x or horizontal components. So we get 5 cos theta on the right side minus mu r on the left side. This total should be 0. Correct?
Yes.
So we are interested in finding mu. So substitute all the values which we know. This, if we send it to the other side, it becomes positive. So 5 times cos theta. Cos theta is 3 by 5 equals mu into r. R is 45.05. So therefore mu equals, this will go away, 3 divided by 45.05. So 3 divided by 45.05. Wow, that's very less. 0.066 or 0.0067. This is the value of mu. Okay.
Yes.
Okay, but he wants us to prove 1 by 15 now. So for 1 by 15 we have to ignore this. Okay, if we ignore this, if we ignore that, then mu will be equal to 3 by 45. So this, if we can cancel, we will get 1 by 15. Okay, so we can just write approx here because we have rounded it off. Okay, next, this 8th one is over. 9th one, let it take. A box of mass 8 m kgs. So mass of the box is m into g. Weight of the box is m into g, m kgs. It is sitting stationary on the smooth plane. Smooth plane means mu is 0. Okay, smooth plane means mu is 0. The plane is inclined at an angle theta to the horizontal. Theta value has been given. So tan of theta is 5 by 12 now. Once again we can draw this triangle theta. Tan theta is opposite by adjacent. So if you use Pythagoras relation, you will get 13 over here. So that means sine of theta will be 5 by 13. Cos of theta will be 5 by 12. So this we got it here. The box of m kg is attached to a second box of small m kg. Okay, that hangs over the pulley. Pulley is again smooth. Pulley is smooth means tension on both the sides of pulley will be same. Show that if the system is to remain at rest, small m by capital M is 5 by 13. So downward force is how much? Small m into g is the downward force. Now if you take free body diagram of this, there are only two forces. Downward force is m into g, tension is upward force. So tension will also be equal to this because action is equal to reaction when there is no friction. Now same tension will act here on this side, and this will be the tension here. Now there are other forces acting on this. There is a normal reaction here. Let's say R. Then in which direction is it moving? Okay, there is no friction, right? there is no friction because it is very smooth. So friction we need not take. We need not worry whether it is moving downwards or upwards. Then we just have to take the y direction and the x direction. Okay, so this is our x axis, this is y axis. Now start solving. So again sigma y, so r is acting in upwards, this angle here will be same as theta, so capital mg um, cos theta, this is acting in negative y directions, okay, downwards, and x will not have any component in y direction, so this total should be 0. So r value is equal to capital mg cos theta. Cos theta is how much? Cos theta is 5 by 12. Let's take 5 by 12. So r is equal to mg into 5 by 12. Then let's take sigma x. So take all the x components. So we have t. T is in positive x direction, so positive t minus capital mg into sine theta. R will not have any x component because it is in y direction. So t will be equal to mg sine theta. Okay. Alright, so what is sine theta? Sine theta, if you substitute 5 by 13 now.
Yes.
So t is 5 by 13. And what is t? T value is m into g now. T value is m
Yes.
into g. So small m into g. So g and g will cancel. So small m by capital M is equal to 5 by 13. So that's what he is asking us to find. Prove. Okay.
Yes.
So just put it here and write hence proved. Any doubts here?
Yes.
Okay, that's it, I think. We have a summary of some key points here: particle or rigid bodies and static equilibrium. So same things that we used to solve the problem. Okay, clear?
Yes.
So next, which topic? Hello? Are you there, Josh?
Yes.
Next, which topic you want?
For the next one, let me see.
Go through the contents. I'll be back.
Yes.
Yes, ma'am. Got it. Okay, so moment. What is a moment first? I think I have explained to you, right?
It's the turning effect.
Sorry.
Turning effect of force.
Turning effect of a force. What is the formula for moment?
It's the force multiplied by the perpendicular distance.
Force multiplied by
Perpendicular distance.
perpendicular distance. Force multiplied by perpendicular distance. That gives us the value of moment. And I think that's going to be sufficient. But do we use vector notation in your case, or we just do graphical? Okay, so there are a few things which require explanation here. Okay, let's take this here. Okay, so here Moment of a force measures the turning energy, then clockwise moment. So if this is the point P, okay, and if you want to find the moment
Yes.
about the point P, then you have to take the force, magnitude of the force, that's what is represented here. Fine, this is the magnitude. So magnitude of the force multiplied with a perpendicular distance. So you can see here the distance is perpendicular, that's what is taken here. Then if suppose P is the point and the force F is like this, but we don't know the perpendicular distance, we know a distance which is acting at an angle theta. If this is the case, then first we need to find the perpendicular distance. Okay, so
Yes.
geometrically speaking, this is the hypotenuse and this is opposite. So opposite is the hypotenuse times sine of theta. Okay,
Yes.
so now if you want to find the force, it will be magnitude of force multiplied by this perpendicular distance. So that's what is taken here. Okay,
Yes.
now there is one more way to solve it. There is one more way to solve it. Many times finding this perpendicular distance is difficult in the problems. So in case of that, what we have to do is we have to take vertical component of the force. We have to take vertical component of force. So what is the vertical component of force? This will be F into sine theta, no?
Yes.
So for this component, d is the perpendicular distance, है ना?
Yes.
And the horizontal component of force, what is the horizontal component? That is F cos theta. It is passing through the point P, है ना?
Yes.
So for this the distance is 0. For this the distance is d. So total moment will be this plus this. This is anyway completely 0. So we get this, that is F into sine theta into d. Okay, so are
Yes.
both these connections are same now?
Yes.
We have just rearranged the sine theta, है ना?
Yes.
So we can either go ahead and take component of force or we can go ahead and take component of distance. ठीक है? So both ways we can apply here. So this is done. Okay, so we have to come here. Okay, so now we are starting with an example. Shall we solve it? Ready?
Yes.
So let's take this. Okay. Find the moment of each force about the point P. So P is the point here. And we know the perpendicular distance. This is perpendicular distance. This is a force. So moment about point P is force into perpendicular distance. That is 3. So this case, the moment is 18. Correct? Whereas here, we don't know the perpendicular distance. We know distance at an angle 35 degrees. So first we need to find this length. What is this length? This length will be d into sine 35. Correct? Josh, are you there? Hello?
Yes. Yes.
Yep. So perpendicular distance, that's the thing. So force is 12 into perpendicular distance, that is d sine 35. D is 8. So here we just need to put 8. Okay, so find it, that's it. So 12 into 8 into sine 35, 55.06. And what is the unit for moment? Unit is Newton meter. Newton
Yes.
meter. Okay.
Yes.
Okay, so next, shall we do this? So here. Okay. Diagram shows two forces acting on a lamina. Find the moment of each of the forces about the point P. Right. So first force, what is the moment? Moment due to this force will be, let's write here itself. Moment is force into perpendicular distance, that is 2. Now this is in clockwise direction. So that is 10 Newton meter in clockwise direction. Then this one, what is the moment due to this force? This will be 8 into, now if here you can take perpendicular distance, right? So this perpendicular distance will be 2 times of sine 50. Okay, or you can take the
Yes.
component of the force itself. If this is confusing you, you can just take the component, the perpendicular component of the force. So what is this component of force? This will be 8 into sine 50 now. Correct?
Yes.
So perpendicular force is 8 into sine 50. For this force, perpendicular distance is 2, and the other component, that is 8 cos, will pass through the point, so its distance is 0. So we will not get any moment due to that. So this is the value of moment. So find it. .88 Newton meters. Okay, and this one is in what direction? This one is anti-clockwise, no?
Yes.
This one is anti-clockwise, this one is clockwise. So if you are asked to find the total moment, the result of both these forces, then let's call it this as m1, this as m2. What you have to do? Total moment. Total moment. So anti-clockwise, let us take it as positive. Clockwise will become negative, है ना?
Yes.
So m2 minus m1. So that is 7.88 minus 10. So we are getting minus how much? 2.12.
Yes.
Minus 2.12 Newton. What is the meaning of minus? Minus means the net effect on the plane is anti-clockwise. Sorry, anti-clockwise we took positive, no? So negative means it is clockwise. Okay.
Yes.
Total moment is this much in clockwise direction. Next we have the exercise. One by one we have to solve all these. Okay, ready?
Yes.
So moment here is very simple. Already force is perpendicular. So this is 3 times 2, that is 6 Newton meter. And it is in clockwise direction, so minus, you can take it as minus. Then this one, here again it is perpendicular distance directly given. So moment is 7 times 1.5, and this one is clockwise. Clockwise means again negative, minus. So 7 5 is 35, 3 7 10.5 minus 10.5 Newton meter. Then here once again you can see the distance is perpendicular to the force, so directly we can take 6.5 times 2, and this is in anti-clockwise direction, so we have to take it as positive Newton meter. So 6.52 times becomes 13 Newton meter, and it is positive. Then coming over here we can see that the force is passing through the point P. So what will be the perpendicular distance? What is the perpendicular distance, ma'am? This distance is given as 3 meters, but that is not
Yes.
perpendicular distance. This is given as 3, but this is not perpendicular distance, right? Force is
Yes.
passing through the point P. That means the perpendicular distance is 0. Okay.
Yes.
So moment also becomes 0. Okay. Moment also becomes
Yes.
0. So next. Next, now we have to find here. So here this is given, so we can either find the perpendicular distance, or we can just take component of force in perpendicular direction. So this component will be 4 times sine 30. Perpendicular distance is 5. The moment is 4 sine 30 into 5. 4 5 is 20, half is 10. So 10 Newton meters in anti-clockwise direction. Hence it is positive. Then this force. So once again we can find the perpendicular component, but if that is becoming complex for you, you can just go ahead and find perpendicular distance, right? So whichever
Yes.
is appearing to be easy, we have to take that path, because there is chance of lesser confusion there. So this is a triangle, this length, this angle is 45 degrees. So this is opposite, so opposite will be 7.2 sine 45. So moment here will be 6 into 7.2 sine 45, and this will be in anti-clockwise direction. So again it is positive. So calculate the value, we can put it over there. Okay, let me leave it that way only. We can calculate it. So once again here the triangle has been defined clearly. So let's go with this method itself. So 2.8 cos 60, correct? This is the perpendicular distance. Force is here. The moment will be 9.5 times 2.8 cos 60. This is the moment here. And finally here the other angle has been given to us. The other angle has been given to us. So we need to be careful. So first we need to find this angle. How much is this angle? 180 minus 137. How much? 43. Correct?
Yes.
43 degrees. Now we can either go ahead take a perpendicular component of force, or you can find perpendicular distance. Perpendicular distance will come somewhere here. Okay.
Yes.
Perpendicular distance is 6.2 sine 43. So moment will be 8 Newton, which is force. 6.2 sine 43. This is the perpendicular distance. We can just feed in the calculator, we will get it. 8 times 6.2 sine 43. 33.83. This is in Newton meters, and this one is anti-clockwise, so it is positive. Okay.
Yes.
A diagram shows sign hanging from the wooden beam. The sign has a mass of 4 kg, so 4 kgs downward. So that means weight will be 4 into g. Calculate the moment of weight of the mass about P. and about Q. So we have to find the moment of this about P. So let us call that as MP. MP will be force, that is 4G, into perpendicular distance. So this is perpendicular directly, so 8, and this is clockwise direction. This is in clockwise direction, hence we have to give it as negative. So 8 4 is 32, minus 32 times G. G is 9.81. So this is MP. Then MQ, moment about the point Q. Moment about the point Q will be force, that is again the same, weight is 4G, times this distance. That distance is total distance 12 minus 8. And this one is in anti-clockwise direction, so it is positive. So 12 minus 8 is 4. 4 4 is 16. So 16 times G. So plus 16 times G is that value. So A bit is over. B bit.
Yes.
Comment on any modeling assumptions you have made. Modeling assumptions. Okay. What assumptions? We know that it is angle is 90 degrees now. I think that is the one assumption we made. Then the weight will be acting in downward direction, and we are assuming that the center of mass of this plate is exactly in line with this. Okay.
Yes.
If the center of mass is somewhere else, then that point will come down. Okay, and the block will become inclined like this or like this. Okay.
Yes.
So those two things we made the assumption of. ABCD is a rectangular lamina, force 12 Newton, acts horizontally. Find the moment of this force about A, B, C and D. Okay, the first moment about A. Moment about A, what will be? What will it be? The force is passing through the point A. So
Yes.
whatever is the force, perpendicular distance is 0. So here it is 0. Then moment about B, it is also passing through the point B. So whatever is the force, perpendicular distance is 0. So 0. Then moment about C. So perpendicular distance here is 3. Okay.
Yes.
So 12 times 3. In which direction? Anti-clockwise direction. So it is positive. 12 3 is 36 Newton meter. And it is positive. And finally, moment about the point D. So for D as well, the perpendicular distance is 3. So we should not take 5. Okay. 5 need not be considered.
Yes.
That is given just for confusing you. Perpendicular distance for this as well as this will always remain 3. So MD is also the same, 12 times 3, and this is again anti-clockwise. That means it is plus 36 Newton meter. Okay. Clear? Any doubt?
Yes, sir. No, sir.
In the diagram, force F produces a moment of 15 Newton meter. So now here moment is given to us. Moment is given to us as 15 Newton meters in clockwise direction. Okay. So find the
Yes, sir.
magnitude of F. Once again we have two options here. One is to go ahead and find perpendicular distance. This will be 12 into sine 30. So if you take perpendicular distance, directly take force F. So formula for M is force into perpendicular distance, that is 12 into sine 30. And we know the value of moment, so substitute here. So 15 equals F into 12 sine 30 is half, that is 0.5. So F will be, this will become 6, 15 by 6. So 3 2s are 3 5s of, that is 2.5 newtons. Okay.
Yes, sir.
And we have resultant moment. So when you have several coplanar forces acting on a body, you determine the turning effect on a given point by choosing clockwise or anti-clockwise. Okay, so I have already demonstrated to you. Clockwise should be taken as minus, anti-clockwise should be taken as plus. Then by comparing, you will be easily able to find total moment. So this is where we are starting to find the total moment. So here the diagram shows the forces acting on the light rod. So this here, let us say it is a light rod, and on this rod a number of forces are acting, and we have been asked to
Yes.
find the moment about this point P, moment about that point P. Ready? So let's take a moment about point P. Because we are finding the sum of all moments, let us call it as sum of MP, or we can find all the moments one by one, like M1, M2 and M3, and then add them all together to get total moment. So first moment, due to 5 Newton. For 5 Newton, the total distance from this point to this point is 3, and it is going in clockwise direction, so this should be minus. So this value we get here is minus 15 Newton meter. Now M2, so let us say this is 1, this is 2, and this is 3. So M2 will be 4 times the perpendicular distance here is this much, that is 1, and this is moving in anti-clockwise direction. Anti-clockwise direction means positive, so we get this as 4 Newton meter. Then third force, M3, this one, that is acting here, and the perpendicular distance is this much, so 3 times 1, and this is moving in anti-clockwise direction, and hence it is positive, so this is 3 Newton meter. Now to add all these, we can just call it as sum of all the moments about point P. So minus 15 plus 4 plus 3, 4 plus 3 is 7, 7 minus 15 is minus 8 Newton meter. Minus means that it is acting in clockwise direction. Okay.
Yes.
So this is how we can find moment. So here some more problems are given. Let's quickly go through them. And here. Okay. So here the point P is here. So shall I do it directly? Sum of moments about point P. Let me do it directly.
Okay, sir.
So first is 3 into 1. This one is moving clockwise, so minus. The next force is 2 into total distance. We need to take total distance, that is 1 plus 3, and this one is going in anti-clockwise, so this is positive. We get minus 3 plus 2 for the 8, that is 5 Newton meter. Now the answer is positive, which means it is in anti-clockwise direction. Find it here. Point P is here, so we get 4 times 2 plus 1. This one is moving in clockwise, so minus. Then 2 newtons into 1, this one is moving anti-clockwise, so plus. Then 3 into 1 again, this one is going clockwise, so minus. So we get 4 to the 8 minus 8 plus 2 minus 3. So here we are getting minus 9 Newton meter. Minus means it is acting in clockwise direction. And coming here, again the point P is here. So 7 into total distance, that is 2, and it is acting in anti-clockwise, so plus. Then 3 times 1, it's acting in clockwise direction, so minus. And 4 times 2, this is acting in anti-clockwise, so plus. So 14 minus 3 plus 8, so that is 17 Newton meter. Now this is positive, which means it is in anti-clockwise direction. Shall I skip this?
Okay.
Okay, let's do this now. So these diagrams show forces acting on a lamina. In each case, find the resultant moment about point P. Okay, so moment about point P. The first force is 3 and perpendicular distance from P is 2. This one is moving in clockwise direction, so minus. The next force is 2, perpendicular distance is 5. Is it clockwise or anti-clockwise? This is clockwise, so minus again. So total moment will be 3 to the 6, 10, so minus 16 Newton meter. Minus means it is in anti-clockwise direction.
Yes.
Then here moment about the point P. Now force here is 4, perpendicular distance is this one, that is 2, and this is moving in clockwise direction, so minus. Next force is 3, perpendicular distance is also 3, and this one is moving in anti-clockwise, so plus. So we get 4 to the 8 plus 9. The answer is 1 Newton meter, and it is positive, which means it is in anti-clockwise direction. Okay.
Yes.
If you feel you can do any problem, you can just let me to skip. Can you do these, or shall we do it? Here the difference is that he has given moment value and he wants us to find the d distance.
Can we just do one question, sir?
Okay, so let's take it the one. The diagram shows set of forces like this. D value is not known here, and that is what we need to find. Moment value has been given, so that means sum of all the moments about P, that is 17 Newton meter. Resultant moment has been given, and this is clockwise. This is clockwise. Clockwise means we have to take it as negative. We have to take it as
Yes.
negative. So minus. Now we have to find the value of d. We have to find the value of d. Now let us take all the moments and add them together. So sum of all the moments, take them one by one. 2 into point is here, so we need to take total distance. Total is d plus 5, no?
Yes.
D plus 2 plus 3, so t plus 5, and this is in clockwise direction, so minus. Then 4 Newton, the distance is 5, and this one is anti-clockwise, that is plus. The next force is 5, perpendicular distance is 3, and this is going in clockwise direction, so minus. So this total, we know the value of MP, substitute here. So minus, this is minus 17 equals minus 2, open the bracket, minus 2d minus 2 5 is 10 plus 4 5 is 20 and 15. So d is the only unknown, we can find it. Okay, so send 2d this side, 17 comes here, this becomes plus 10, 10 minus 15 is minus 5. So d is 12 by 2, that is 6. Okay, what is the
Yes.
unit? All the distances are given in meters, so d is also in meters. This is the answer. Any doubts?
No, sir.
Fourth one is also similar, can you do it?
Yes, sir.
Next, calculate magnitude of reactions. Diagram shows uniform rod. Weight, okay, weight is given for the rod. So here the diagram is given, rod AB is given, and the weight of the rod is 20 newtons. Total length is 3 meters, and we can assume that the rod is uniform. Okay, if the rod is uniform, its weight will act at the center. No, center means 1.5 meters, right?
Yes, sir.
And weight is 20 newtons. Now to support this rod, we will get two reactions here. So let us call this as RA. Reaction here, let's call it as RC. Calculate the magnitude of reactions. So now we have to find the reactions. Okay, so once again we
Yes.
will have the three equations of motion. What are the three equations of motion? Sigma H should be 0, sigma V should be 0. Now these are the two equations which we have been using till now. Now we have one more equation we get, that is sum of moments about any point is also equal to 0. Okay, now this point
Yes.
can be any point. This point can be A, this point can be C, this point can be this point, this can point with this point. The point can also be, away, it need not be on the diagram also, it can be some other point also. Okay, about this point also, if you take sum of all the moments, it
Yes.
should be 0 because the object is in equilibrium. So now using these diagrams, these formulae, we have to find the reactions RA and RC we need to find. So first, there are no horizontal components, so let us start with vertical components. RA is acting upwards, RC is acting upwards, and 20 is acting downwards. There are no other forces, so this total should be 0. That means RA plus RC equals 20. Okay, now sigma
Yes.
H we cannot take because there are no horizontal components, but we need to find RA and RC. So for that, we have to take sum of moments about some point. Which point you want to choose? If I choose this point, I will get RA and RC both in the equation. Okay.
Yes.
And this is one equation. We can take the other equation as second equation. We can solve that, but that becomes a bit difficult, right? So we should choose our points in such a way that one unknown, at least one unknown, will get cancelled. Okay, so we can either go with moment about A or we can go with moment about C. Which one you want to take? Let's go with A, for example.
Yes.
Then RA, the moment due to RA will be 0 because it is passing through the point A. Next 20, for 20 that perpendicular distance is 1.5 and it is in clockwise direction, so minus. Then RC, for RC the distance is 2 meter and this is going in anti-clockwise direction, so that has to be plus. There are no other forces. RA, moment due to RA is of course 0, so this total should also be equal to 0. This total should also be equal to 0 because the object is in equilibrium. Now find the value of RC. RC will be 20 into 1.5 by 2, that is we get 10, so that is 15. So RC value we got it as 15 newtons. This value if you substitute, you will get value of RA. RA value is 20 minus RC, that is 20 minus 15 or 5 newtons. Clear?
Yes, sir.
So this way you can use moments to find unknown reactions. Wow. So shall we solve this or shall we go for exercise directly? Hello? Josh?
Yes, sir.
Shall we solve this or go for
Yes, sir.
Okay. Let's take this. Okay. Space is not enough. Okay, so we have here a uniform beam AB of mass 40 kgs and length 5 meters. Total length of the beam is 5 meters. It rests horizontally on supports C and D, where AC is equal to dB. AC and dB are both equal to 1 meter. When a man of mass 80 kg stands on the beam at E, magnitude of reaction at D is twice the magnitude of reaction at C. So reaction at C, let us call it as RC. Reaction at D, let's call it as RD. So he is giving the relation between RC and RD. So according to him, RD is equal to twice the magnitude of RC. So this data is given. By modeling the beam as a rod and man as particle, find the distance AE. So he is asking us to find this length AE. What will be the length CD? What will be the length CD? CD will be 5 minus 2 because the total length of the rod is 5 meter. 5 minus this 1 and 1, so we get 5 minus 2. So CD is 3 meters. CE is unknown, that is x meters. We have to find that x. So now let's remove this. The weight of the person is 80 kgs. So 80 into G, 80 into G, and let us say the midpoint is here. If midpoint is here, the weight of the rod will act here. Weight of the rod is 80 kgs. Sorry, 40 kgs. 40 kgs. So 40 into G will be the weight of the rod. 80 into G will be the weight of the person. And this distance, okay, x distance is this total distance. X distance is this total distance, and this distance is how much? This distance will be half of CD. This distance will be half of CD. CD is 3, so 3 by 2, that is the distance for the rod. So having known all these values, we should be able to find the value of x. Ready?
Yes, sir.
So again we have the three equations with us, sigma v, sigma h and sigma m. Let us start with sigma v. So RC is acting upwards plus RD is acting upwards minus 40G is acting downwards and again 80G is acting downwards, so minus this total should be equal to 0 because the beam is in equilibrium. Give me a minute.
Yes,
कॉल करता हूँ. So we get RC. Acha, we can substitute the value of RC now.
yes,
So RD value we can substitute here. So we get RC plus 2 times RC minus 40G minus 80G equal to 0. Okay, so we get 3 times RC equals 40 and 80 becomes 120. On the other side it becomes positive. So 120G. 3 becomes 40. So RC value is 40G. Okay,
yes, sir.
RC value is 40G. But this is not what he is asking. He is interested in knowing the value of X. In order to find the value of X, we have to take sigma moment, sum of moments equal to 0. Moments, again we have to choose some point. Which point you want to choose? I told we should choose it such that one of the unknowns will become 0, but RC and RD both we have found anyway. RC value is known. Let's go with moment about D. Okay, moment about I think moment about D, if you take again it becomes complex. So let's go with moment about C itself. Moment about C. So what is moment about C?
Yes,
RC will not have any moment because it is passing through point C. 40G, the perpendicular distance is 3 by 2, है ना?
yes,
And it is in clockwise direction, so minus. Then 80G, the distance is X and it is acting in clockwise direction, so minus again. Then RD, the distance is 3, है ना? And this is acting in anti-clockwise direction, so positive, correct?
yes, sir.
So this total should be equal to 0. So here how many unknowns are there? RD is also unknown, but we can substitute RD from here. Okay, so 0 equals this becomes cancelled, minus 60G minus 80GX plus 2 times RC is 40G into 3, correct?
Yes,
So now we are interested in X. So X equals 2 3 is 6, 6 4 is 24, so 240G minus 60G, and this 80G will be on this side now. It will become positive. 80G will be this side if you send it this side by 80G. So find X. So 240 minus 60, G will get anyway cancelled, so I will not take it, divided by 80. G can be taken common and we can cancel it. So X value is 2.25 meters. Okay,
yes,
so X value 3.25. To find the distance, okay, A to E is he wants us to find. Okay,
yes,
he wants us to find A to E. So A to E will be 1 plus X. that is 3.25 meters. Okay.
Yes.
All right. And here we have the exercise. Okay, AB is uniform rod of length 5 meter, weighs 20 newtons in the diagrams. AB is resting in horizontal position on the support C and D in each case, and the magnitudes of reaction C and D. Okay, so in each case we need to find the magnitudes. Okay, so here the distance AC and DB are equal, and this will be acting at the center. Okay,
Yes.
so this weight is 20 newton. So because it is acting exactly at the center, we will get both RC and RD to be equal. By common sense itself we can tell it, but let us solve it by this thing. So because it is acting at the center, this distance will be 1.5 meters. So here reaction is RC, reaction is RD. So RC plus RD, we will get it as 20, correct?
Yes.
I'm directly writing the equation. Then if you take moment about which point, let's take about C point. So 20 into 1.5 clockwise, so minus, then RD into 3, this is anti-clockwise, so plus, this total should be 0. So RD will be 20 into 1.5 by 3. So okay, 5 to the 10. Okay, so
Yes.
RD is 10. Then same way RC, if you want, you can take it as 20 minus RD, that is also 10. Okay,
Yes.
here this one will be slightly different. Okay, so it will act at the center, 20 newtons. Center means from this end to this end will be 2.5. So this distance will be 0.5, correct?
Yes.
Once again RC plus RD will be 20, and if you take moment, let's take about C. What happens? Moment about C, that is 20 into 0.5 clockwise, and minus RD into 2, correct? Sorry, this is plus, this is clockwise, so plus, sorry, this is anti-clockwise, so plus, this is clockwise, so minus. The total should be 0. RD equals 20 into 0.5 by 2, that is 20 by 4. 20 by 4 is 5. Okay, so RD value is 5 newtons, and RC will be 20 minus RD, that is 15 newtons, correct?
Yes.
So can you solve these, the other two? Can you do it, or you want me to do? Let's do one more.
Yes.
Okay, so 2.5. So let's say this is here. So this distance will be 2.5. 2.5 minus 1, we get 1.5 here. Okay.
Yes.
So let's take RC plus RD. Again it is 20. Now moment, let us take about D point. Moment, let us take about D point. We can take about C point also, but for that we just need to find this length. This length will be 2.5 minus 1.5. This is 1. Okay, I think that will be simpler. Okay, but anyway, let's go with simple way only anyway. So let's remove this. Let's take moment about C. This is 20 newtons. So 20 into 1, this is clockwise, so minus, the other force will be anti-clockwise, so RT into 2.5. the total should be 0. So RD 20 by 2.5. 20 by 2.5, what do we get? We get 8 now. 8 newtons.
Yes.
Then RC will be 20 minus 8, that is 12 newtons. Okay.
Yes.
Can you do this last one? Shall we do it? Only the lengths have been given a little in a complex way. That's it.
Okay, sir. Yeah.
So if you take 20 here, so this total distance will be 2.5. 2.5 minus 1.5, we get 1 here. Okay.
Yes.
And then the entire process is same as before. Okay.
Yes, sir.
So shall we stop after this today?
Okay, sir.
What time did we start? We started at 4:20 now.
Around that time.
Okay. So this will be our last problem today. Each of these diagrams shows light rod in equilibrium in a horizontal position under the action of forces. Find the values of unknown forces and distances. Okay, some distances are also unknown here. Like here in third problem, D distance is unknown. In this case, X and Y, two forces are unknown. Okay. So A bit, again we have to start with sigma vertical. All vertical forces, take them. So X is acting upwards plus Y is acting upwards, minus 10 because downwards, minus 15 again downwards. So X plus Y becomes 25. This is equation 1. Again let's take moment about a point. So we have to choose a point such that one of the unknowns will get cancelled. So let us take moment about A here. So now moments due to all the forces we need to take. So first 10. For 10 the distance is 1. So 10 into 1 and it is in anti-clockwise direction, so positive. X will get cancelled because it is passing through A. For Y the distance is 2. This is going anti-clockwise, so anti-clockwise is positive. And then 15 total distance 3 we need to take, and this is going in clockwise, so minus. This total should be equal to 0. So here we have 2y equals 15 times 3 is 45 minus 10 on the other side. So we get 35 by 2 as the value of y, that is 17.5. Okay.
Yes.
Then if you substitute this value back here, we will get the value of x as 25 minus 17.5. That how much we get? 5.5. It's slightly confusing. Let's do it. 25 minus 17.5, 7.5.
Yes.
Okay. So x and y both values we found. So here second one, B bit, is again the same. So instead of x and y in same direction, they are in opposite directions now. So 15 is upwards, so sigma v, no, sigma vertical, all vertical components. So 20 is downwards, so minus 20. 15 is upwards, so plus. Y is upwards, so plus. X is downwards, so minus. So total 0. So y minus x will be 5. This is equation 1. Sigma moment. Moment again we need to take about a point which makes one of the unknowns as 0. Let's take about this point A. Moment about point A. So 20 20 times total distance, that is 5, and this is moving in anti-clockwise, so plus. Then 15 times this distance, that is 3, this is going in clockwise, so minus. Then y times 1, this is going clockwise, so minus. Total should be 0. So y will be equal to 20 into 5 minus 15 into 3. So what do we get? $55. Okay.
Yes.
So y value is 55, and then substitute this here. We will get the value of x. So 55 minus x equal to 5. So 55 minus 5 equal to x. So x is 50. Okay.
Yes.
These are the x and y values. In this one, C bit, the distance is unknown and x is unknown. So again, let's go with sigma vertical. 5g is downwards, so minus 5g. 5g is upwards next, so plus 5g. 10g is downwards, so minus 10g. X is upwards, so plus x, minus 15g downwards. Total should be 0. So here we will get the value of x directly, right? These two will cancel, and that is 25g, correct?
Yes.
So this gave us the value of x. And to find the value of d, we have to take sigma m. So which point you want to take? Let's go with this point, b.
Yes.
So sigma m about b. If you take about b, x will cancel out. Yeah, we can take it, no problem. So let us start. So 5g perpendicular distance is 2 plus 2 plus 3, that is 5 plus 2 7, right?
Yes.
This is anti-clockwise, so plus. Then upper 5g the distance is 5, so 5g into 5. This one is going clockwise, so minus. Then 10g into distance is 3. This one is going anti-clockwise, so plus. Then 15g, then this one is going clockwise, so first let us take distance. 15g into d, this one is going clockwise, so minus. Total should be 0, correct?
Yes.
So this total term sent to the other side. So this side, what do we get? 5 into 7. Okay. 5 into 7 minus 5 into 5 plus 10 into 3. I'm not taking the values of g. Okay, why am I not taking the values of g? Because g will anyway come out common and it will cancel, right?
Yes.
So 40g on this side. On the other side we get minus becomes plus 15gd. So g will get cancelled. D will be 40 by 15. Okay, so 5 3s are 5 8s are 40. So 8 by 3 or 2.67, right? Any doubts?
No, sir.
So we'll stop here. We'll take it up next tomorrow at same time, 4.
Yes.
Okay. Tomorrow is Sunday. If you want any other time, we can take that as well.
No, sir, it's fine. We can keep it the same.
Okay then. Bye.